periodic table, we have hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. After that, they are continuing like that only. Sodium, magnesium, actually I have to write helium over here, and then potassium and calcium. There are more elements also, but to explain the mole concept, these are enough. So actually, what is mole? You know about atomic number and atomic mass. The atomic number.
Y- Yes, sir.
Atomic number is number of protons. Number of protons present in the atom. So for hydrogen, it is one proton plus one electron over here and zero neutrons. For helium, this is for hydrogen. For helium, it is two proton plus two electrons plus two neutrons. The neutron and proton are in the nucleus and electron revolve around the nucleus. Okay. Now atomic number is the number of proton. So for hydrogen it is 1, for helium it is 2, then 3, 4, 5 and so on. It is written up to 20. But the atomic mass is equals to number of proton plus number of neutrons. Number of neutrons. So the proton are equals to the number of electrons, but the neutron are either equal or can be more than or can be less than the number of protons. So for hydrogen there is zero neutron, so the atomic mass of hydrogen is 1 only, and atomic mass of helium is 4. For lithium it is 7, and it is 9, 10, 12, 7 or 15, 14 basically, 8, 16, 9, 18, and 10, 20, 11, 23. 11 is the atomic number and 23 is the atomic mass. That means it has 12 number of neutrons. 12 neutrons plus 11 protons in total in sodium. Okay, ma'am. Now
Okay.
coming to the mole. When we write the atomic mass, we write it for the single atom. Its unit is unified mass or U, or the earlier it was used as AMU, the atomic mass unit. Okay, ma'am. But when we have to write it in the form of grams, just like we write that the atomic mass of hydrogen is 1 gram. So this 1 gram is equals to the mass of the mole. So 1 gram per mole we have to write. For the scientific calculations, we cannot use atomic mass unit as U or AMU because it is for the single atom, and single atom cannot be identified with naked eye, or we cannot take the single atom for any reaction. So we generally take the mole, and 1 mole of any element contains 6.022 into 10 raised to the power 23 atoms or molecules. Okay, ma'am.
Okay.
It is a specific number. The mole is nothing but the specific number of particles, atoms or molecules. Either I am taking sodium. So sodium exists as a single atom, not as a molecule.
Yes.
So when I write 1 mole of sodium, 1 mole of sodium, I mean to say that there are 6.022 into 10 raised to the power 23 atoms of sodium. Okay, ma'am.
Okay.
And when I write one mole of 1 mole of hydrogen. So I mean that 6.022 into 10 is to 23 atoms of hydrogen. When I write 1 mole of H2 gas, then I mean that there are 6.022 into 10 is to 23 molecules of H2. Got
Okay.
my point? When there is single atom, then
आप
I write yes, ma'am.
मैं सब कुछ करती हूँ। ये फिक्स रहता है ना 6.02 to 10 to the power for every element.
For every element, it is same. But in case of mass, this particle number remains the same, but the mass for each element of these much particles is equal to the atomic mass. The
Okay.
atomic mass in U is equals to the gram atomic mass or gram molecular mass. That gram molecular mass will be equals to the mass of 6.022 into 10 raised to the power 23 particles. Okay, ma'am.
Okay.
6.022 into 10 raised to 23 particles of that element, but it will remain same as that of atomic mass unit. Now it is clear, ma'am.
Okay. Okay. Clear, sir.
Coming to the balanced equations. Okay. Coming to the balanced equations, when we write the skeletal equations, we write it like H2SO4 plus NaOH give us H2O plus Na2SO4. Now you can see that the number of sodium is 1 over here and number of sodium atoms are 2 over here. Yes, ma'am. Number of
Yes, sir.
hydrogens are 3 over here and number of hydrogen is 2 over here.
Yes.
Oxygen is also not balanced. Okay, ma'am. So this is called as skeletal equation. When we generally write chemical formula of the compound, of the reactants and chemical formula of the products, generally it is a general equation. But when we used to uh, write in exams or write in a specific manner, we have to balance the equation with by putting some stereochemical coefficients, which are the number of moles actually, that how much number of moles of this reactant plus how much number of moles of this reactant are reacting together to give the products. Okay, then. So this time when I want to balance the equation, I will check for the each and every element to be balanced on both sides. So look over here that like sodium, it is 2 in the product side and it is 1 in the reactant side. So I will put 2 over here. So the sodium will be balanced. Okay, ma'am. The sodium is
Okay.
balanced. Now I will look for the hydrogen and oxygen. So this SO4 is balanced over here. So we will not look for this. Now I will look for this OH and this H2. Here, how much hydrogen I have become? It is 4 hydrogen and 2 oxygen. So I will put 2 over here also. Now this equation is balanced. Okay, ma'am. Just read out these points. The chemical equation must be written in accordance with the law of conservation of mass. So I have conserved the mass. Here there are total number of moles 3. Here the total number of moles are 3. So the mass is conserved. And law of conservation of mass shows that mass can neither be created nor be destroyed. In a chemical reaction, total mass of the reactant is equal to total mass of the product. Yes, ma'am.
Yes, sir. Yes, sir.
And the balanced chemical equation is one in which the atom of each and every element must be equal on the both sides. So like I have balanced sodium first of all, 2 sodium over here, 2 sodium over here. After that I balanced oxygen and hydrogen in the form of water over here. Yes, ma'am.
Yes, sir.
The following elements are used in diatomic state while writing the chemical equations like hydrogen. Like I want to write this equation. Hydrogen plus oxygen will give me H2O. So I have written these gases in the diatomic form. The hydrogen, fluorine, chlorine, bromine. The chlorine will also be like that. H2 plus Cl2 will give me HCl. And for balancing, I will put 2 over here. And for and here for balancing, I'll put 2 over here, 2 with the hydrogen. Wait for a second. H2, 2H2 plus O2 will give me 2H2O. So I'll balance each and every element. The other element can be treated as if they were monoatomic, like sodium. Here, the sodium hydroxide, or I'll write it as Na plus Cl. This is the hypothetical equation. Na plus Cl is not does not come in any equation. The equation can be NaOH plus HCl will be equals to NaCl. But I'm writing the hypothetical equation over here that Na plus Cl will give NaCl. Just to show you that we will write the gases only in diatomic state, not every element. Like sodium, I have written as Na, and Cl I have written as Cl. But I have to write Cl as Cl2 because Cl is a gas, chlorine is a gas, so I have to write it as diatomic molecule Cl2, and it will be like 2Na plus Cl2 will give me 2NaCl. Okay, ma'am. Is it the doubtful case? Ma'am, are you there? Ma'am, are you there?
सर क्लोरीन का जो पॉइंट बताया था ना वो बता दीजिए एक बार।
Chlorine का point, yes, ma'am. I was writing this equation, na? Na plus Cl2. The chlorine is a gas. Like you can see over here, the following element are used as diatomic state. In these are all the gases. H2, F2, Cl2, Br2, I2, O2, and N2, the nitrogen gas. These are written as diatomic molecules. Like over here, in the case of this hypothetical equation, I have to write Na plus Cl2. The Na is a metal, so I have written it as single unit, monoatomic unit, and it will give me NaCl. If I want to balance this, I have to put 2 over here and 2 over here. Okay, तो मैम ये वाला पॉइंट क्लियर हो गया ना, दैट गैसेस को हम डायटोमिक मॉलिक्यूल की तरह लिखेंगे और बाकी एलिमेंट्स जो होते हैं हमारे एक्सेप्ट गैसेस को हम लिखेंगे डायटोमिक मॉलिक्यूल की तरह एक्सेप्ट द नोबल गैसेस। जो जो हमारी नोबल गैसेस होती हैं उनको हम मोनोएटॉमिक फॉर्म में ही लिखते हैं, जैसे हीलियम, नियॉन, आर्गन, क्रिप्टन, xenon, and radon. These are written in the form of monoatomic gases. Rest all are written in the form of are written in the form of diatomic gases. Okay, ma'am. मैम समझ आया
सर
ये
यस सर,
कंसेप्ट
यस
आपको?
सर, यस सर, यस सर।
Okay जी. So we'll look for some other examples of the balanced equations, just like zinc plus, I'm writing the word equation first. I'm writing the word equation first. Zinc plus sulfuric acid, sulfuric acid will give me zinc sulfate plus hydrogen gas. Hydrogen gas. Now I'll write it as the skeletal equation. Zinc, symbol of zinc plus sulfuric acid formula will give me ZnSO4, will give me ZnSO4 plus hydrogen gas. Now I have to balance this. Just look at this. The balanced equation is similar to that of the skeletal equation because there is nothing to balance over here. H2,
Yes, sir.
H2, SO4 with SO4 and zinc as zinc. Again, now this one example. Magnesium plus HCl will give me MgCl2 plus hydrogen gas. Now, can you balance this equation, ma'am? Just tell me the coefficients.
Uh, 2 HCl.
2 HCl, okay. 2 HCl. And, ma'am, it is balanced, na? Or
Hmm.
we have to write something else also.
Balanced है. Mg1.
Yes, ma'am. Yes,
Yes,
ma'am.
sir, balanced है.
Yes, ma'am. It is balanced, ma'am. Nice one, ma'am. Just wait for a second. I have to add a new slide. We will do some examples for balancing so that everything should be clear.
Sir, let's continue with the theory part. Actually, balancing of equation मैंने पढ़ा है.
जी
वो मतलब मैं भी टीचर हूँ तो मैंने अभी 7th क्लास तक पे पढ़ाती थी साइंस में, तो उससे करवाया है बच्चों को. अगर कुछ
यस
नया है, सेवेंथ में बेसिक बैलेंसिंग था जैसे अभी हम कर रहे थे,
जी
उसके
वो
अलावा कुछ एक्स्ट्रा है तो वो करवा दीजिए.
जी श्योर मैम.
ओके.
So the steps of balancing the chemical equation, you are ready. Now the types of chemical reaction. This is the new concept in class 10th. The types of chemical reactions. The combination reaction, decomposition, displacement and double displacement. I am sure that you will be familiar with the names. The combination reaction. What is combination reaction?
यस
What is
सर.
combination displacement and double displacement? So
यस.
I will directly come to the point that combination reaction, there is a combination of two or more reactant to form a single product. Just like we were doing earlier, actually each and every most of the reactions are combination reactions. Either it is combustion reaction or it is the formation of salt neutralization reaction or anything else. It is the example of combination reaction. Like our first example was this Mg plus O2 that will be giving MgO, and this is a combination of magnesium and oxygen. And other examples are CaO. It is also the old example. Plus H2O will be giving CaOH whole twice. The the two reactants combine together to form the new product. It is the example of combination reaction. Now decomposition. The decomposition reaction was like this: that CaCO3, I decomposed it in the presence of heat to give CaO plus CO2. It is a decomposition of the compound. That means the compound is decomposed or uh, fragmented into the simpler parts.
ओके.
Okay. Basically, the definition says the reaction in which single substance is broken down or split into the two or more simple substance under suitable conditions. Just like uh, we discussed about CuSO4 dot 5H2, and when I heated it, it is decomposed into CuSO4 plus 5H2O in the form of gas. It is evaporated, and it is the white mass. What is the actual color of CuSO4? The actual color of CuSO4 was blue. It was due to the presence of this, the water of hydration. Okay, ma'am. Similar case with will be with FeSO4.7H2O. When FeSO4 is heated, it is formed the dirty white mass or the white mass, and the water is evaporated. It is the example of decomposition reaction. Or the other example of decomposition reaction can be 2FeSO4, when it is heated, it is converted into Fe2O3 plus SO2 plus SO3. So it is converted into the simple ferrous oxide, basically ferric oxide, sorry, not ferrous oxide, ferric oxide. Its color is brown. What was the color of FeSO4? Light green. The color of FeSO4 was light green, and when we heated this, we got the brown mass, which is actually the oxide of iron. Now the next type of reaction is displacement reaction. You know about the
सर
reactivity?
रस्टिंग ऑफ आयरन जो है उसको भी ले सकते हैं डिकम्पोजिशन में?
Yes, rusting of iron. Ma'am, rusting of iron cannot be taken as the decomposition reaction. It is the type of redox reaction in which iron is oxidized to form iron oxide, and it can be basically come into combination reaction because here iron will get combined with oxygen to form Fe2O3, the ferric oxide. Okay, ma'am, or Fe3O4. So it is basically the combination of iron with oxygen. It is not the decomposition. The decomposition means the breaking of the complex compound into simpler compounds. Is it clear, ma'am? Or shall I
यस,
repeat?
नहीं नहीं सर आ गया.
Okay, ma'am. Now, next example. The next type is our displacement reaction. So for the displacement reaction, we have to be familiar with the reactivity series. Here, potassium, calcium, sodium, magnesium, aluminium, and it goes on. Gem, oh, me. Actually, the space is less, so I'm writing this the sideways. I hope there will be no problem. SNPB, hydrogen, hydrogen. After that, non-metals will come. First of all, the copper will come, then silver, gold, and lastly platinum. Okay, ma'am. So this is reactivity series. These elements are in the decreasing order of reactivity towards the downward side. So this is the most reactive metal or the most reactive element in whole of the whole of the periodic table. So in displacement reaction, the more reactive metal, the more reactive metal more reactive metal will displace less reactive metal from their salt. एग्जाम्पल के लिए हम देखें तो when I dip iron nail in copper sulfate solution, when I dip iron nail in copper sulfate solution, the nail will be turning brown and the color of the solution, which was earlier blue, will be converted into green, which means that copper is at the lower place in the reactivity series. Therefore, the iron will be displacing copper from its salt, and there will be the formation of ferrous sulfate, which is green in color. and the brown coating over the iron nail is of copper. So basically iron displaces copper from the copper sulfate solution. Okay, ma'am.
Okay.
Now should I give some more example or
सर इसका इक्वेशन बता दीजिए मुझे, ये जो आपने एग्जांपल दिया है
yes,
इक्वेशन फॉर्म में.
sure, ma'am, sure. Here I have to write Fe plus CuSO4 aqueous. We have to actually write the state of the reactants also and products also. So it will be giving FeSO4 aqueous, FeSO4 aqueous plus copper. The FeSO4 will be green in color and the CuSO4 was blue in color. Okay, ma'am.
Yes, sir.
Now we'll come to the previous slide. The next one is double displacement reaction. The next one is double displacement reaction. We will be speaking about that. What is double displacement reaction? In displacement reaction, there is a single aqueous solution which is displaced by some metal. Now, in the case of double displacement reaction, there will be, in case of double displacement reaction, there will be the two solutions. Just like we given an example of BaCl2 plus Na2SO4, which given me BaSO4 plus 2NaCl. So here sodium displaces barium from its solution and barium displaces sodium from sodium sulfate to give barium sulfate plus sodium chloride. Okay, ma'am. Here two solutions are mixed and the cation of each solution will displace each other's anion. We can give more examples too for this. Like it is basically in the precipitation reaction where there is a double displacement, like AgNO3 plus NaCl. Both will be displacing each other's anion and will give AgCl, white PPT, plus NaNO3. More will be like BaOH whole twice, BaOH whole twice, BaOH whole twice plus NH4Cl, that will be giving NH4OH plus BaCl2. So these both cations are replacing each other in their aqueous solution. Is it clear, ma'am?
Yes, yes, sir. Yes, sir.
Okay. Now, hope you can differentiate between displacement and double displacement reaction, or should I tell you first?
डबल डिस्प्लेसमेंट में सर दो अलग अलग कंपाउंड बनते हैं डिस्प्लेस होने के बाद.
दो अलग अलग
ऐसा है
कंपाउंड
ना?
बनते हैं हाँ जी, दो अलग अलग कंपाउंड बनेंगे डिस्प्लेस होने के बाद, जिसमें कि
हाँ.
एक कंपोनेंट ईच रिएक्टेंट का एक दूसरे को डिस्प्लेस करेगा.
हाँ, तो सर कौन किसको डिस्प्लेस करेगा वो कैसे डिसाइड होता होगा?
मैम दोनों के केटायन है ना,
अच्छा।
दोनों के केटायन है, लाइक यू सी इन दिस इक्वेशन, हियर इज बेरियम, here is
हम्म।
ammonium cation NH4 positive. These both are
हम्म।
displacing each other from their solution and
ओके।
giving the totally new product like NH4OH and BaCl2.
ओके।
So there is no reactivity series over the double displacement reaction. The reactivity series will work only in the case of displacement reaction where there is one metal and one is the salt.
ओके।
Okay, ma'am. Now the next type of
मैं आप
reaction will
मतलब
be.
ये कह रहे हैं कि जो कैटायन है वो एनायन के साथ कंबाइन हो रहे हैं ऐसा?
हाँ जी, हाँ जी।
ओके। सर ये जो इक्वेशन ये बैलेंस नहीं है ना, NH4OH?
नहीं ये बैलेंस नहीं है, आप बताइए, बैलेंस बैलेंस कर दीजिए इसको।
बैलेंस सर, तो 2 लगा देंगे NH4Cl के आगे।
जी ठीक है, 2 लग गया यहाँ पे।
इसमें भी लगाएंगे ना सर 2?
हाँ जी, इसमें भी 2 लगेगा, इधर भी।
हाँ, NH4।
NH4OH के पास अब हो गई है बैलेंस।
हाँ, अब बैलेंस कर दिए।
जी मैम।
ठीक है। और
ठीक
सर
है,
जैसे हाँ,
जी बताइए।
ये जैसे 2NH4 या ऐसे कोई भी हम रिएक्ट करते हैं तो जैसे 2Na, तो ये जो मतलब 2 मोल के बराबर होगा ना?
हाँ जी मैम।
एटम्स नहीं होता है वो, मोल मोल होता है।
हाँ कुछ टीचर्स उसको ना एटम की तरह बढ़ाते हैं, बट इट इज नॉट पॉसिबल।
हाँ।
यू थिंक कि
हाँ।
क्या हम 2 एटम को उठा के ऐसे रिएक्ट करा सकते हैं?
नहीं नहीं नहीं।
तो वी
वी
हैव टू
हैव टू
टेक
टेक
सम
सम
क्वांटिटी,
क्वांटिटी।
सो इट इज कंसिडर्ड एज अ मोल।
ओके। ठीक है।
ठीक है मैम। नाउ
हाँ।
कमिंग टू द नेक्स्ट टाइप ऑफ रिएक्शन इज प्रेसिपिटेशन रिएक्शन. The precipitation reaction examples I have given here. Again, I will write like sorry, this screen tend to come again and again and again. BaCl2. ये ना परेशान कर रहा है. The BaCl2 plus Na2SO4 will be giving me BaSO4 plus 2NaCl. This BaSO4 is insoluble in water, so it will give me white PPT. White PPT. Next one example is AgNO3 plus NaI, sodium iodide, will give me AgI plus NaNO3. Here the AgI is also insoluble in water and will give me dark yellow PPT. Dark yellow PPT. Okay, ma'am. So these are some examples of precipitation reaction. There are a lot more of reaction which form precipitate. Should I give some more or not? Okay, let me give some more.
प्रेसिपिटेट रिएक्शन और डबल डिस्प्लेसमेंट में क्या डिफरेंस है? ये तो मुझे सेम लग रहा है।
These are both same, ma'am. These are both same. There is no difference.
ये डबल डिस्प्लेसमेंट और प्रेसिपिटेट में?
Yes, ma'am. Yes, ma'am.
ओके।
These are both same. Actually, the double displacement reaction is the large group of reaction because some double displacement reaction do not form precipitate, but some double
ओके।
displacement reaction form precipitate. So the precipitation reaction is a sub part of double displacement reaction.
ओके।
Next is combustion reaction. We will talk about the combustion reaction now, and after that redox and neutralization. So first of all, let's talk about the neutralization reaction. These are also similar to the double displacement reaction. For example, I'll write Zn. I'll write ZnOH whole twice plus HCl, or either I'll write 2HCl, that will give me ZnCl2 plus 2H2O. Okay, ma'am. So this is the neutralization reaction. It is base, it is acid, and they neutralize to form the salt. And it is also the part of double displacement reaction. Other one is NH4OH, NH4OH plus HCl, that will be giving me NH4Cl plus H2O. This is also the double displacement reaction plus the neutralization reaction because there is a formation of salt. The, the definition of neutralization reaction: when one acid and a when an acid and a base react with each other, they neutralize each other and form salt plus water. This is called as neutralization reaction. Okay, ma'am. Is it clear, ma'am?
Yes, sir.
Next one is combustion reaction. Next one is combustion reaction. So the combustion reaction can also be classified as combination reaction because in combustion reaction the element or some compound will react with oxygen to form the new product. Like the most common example is burning of coal. So the coal is burned in the presence of oxygen to give me the number of products like carbon monoxide, carbon dioxide. In the case of carbon monoxide, the supply of oxygen is limited, but when the oxygen is in excess, a complete combustion of carbon will be there and carbon dioxide will be formed. Next one is the oxidation of sodium. So that it will be giving me Na2O. This is also the type of combustion reaction or the oxidation reaction because we heat the sodium. If we heat the sodium or if we put sodium, as the sodium is very reactive metal, so we do not need to heat it in presence of air. It spontaneously react with the air to burn down and form sodium oxide. Okay, ma'am. So this is the example of combustion reaction when we heat something in presence of oxygen to give the product. Is it clear, ma'am?
नहीं सर, एक बार और बता दीजिए, नहीं आया समझ में।
Yeah, sure, ma'am. कोई बात नहीं, मैम. Like I'm burning something, like I'm burning paper. So paper contain carbon, hydrogen, oxygen. Actually, it is the cellulose. So carbon, hydrogen, and oxygen. And actually, what it gives: water vapors plus carbon dioxide. When it
तो
is
आप बोल रहे हो कि कंबशन रिएक्शन जो है उसमें ऐसा जरूरी नहीं है ना कि हर कंबशन रिएक्शन में कार्बन डाइऑक्साइड गैस मतलब प्रोड्यूस
नहीं,
होगी।
नहीं. Ma'am, actually, the carbon dioxide, the production of carbon dioxide will depend on the presence of this, the presence of carbon. If anything is containing carbon, it will surely give either carbon monoxide or carbon dioxide. Like when we heated calcium carbonate, when we burned calcium carbonate, it gave me calcium oxide plus carbon dioxide. Okay, ma'am. Plus carbon dioxide it gave me. So if the compound will be containing carbon, then
So this last one is the example of decomposition also and combustion also.
yes, ma'am.
CaCO3.
Yes, ma'am.
Okay.
Because we are heating it, na?
Yes, sir.
Because we are heating it or subjecting it to strong heat.
ये Na वाला एग्जांपल एक और बार बता दीजिएगा।
Na wala example is basically under oxidation reaction also. Here,
ओके।
sodium is spontaneously reacting with oxygen. There is no need of heat because it is very reactive metal. As
Yes,
you have
sir.
seen in this reactivity series, it is on the third number. So we can say that it is very reactive metal. So it will spontaneously react with oxygen or the air to form sodium oxide, which is Na2O. Okay, ma'am?
Okay. Sodium oxide is a solid compound.
Solid substance, ma'am.
Okay. ठीक है सर.
So solid white mass. Actually, when it burns, it gives solid white ash. White ash. Now coming to the next point, or coming to the next point, the redox reaction. And the redox reaction. So what is redox reaction? What is redox? I'm sorry. What is redox reaction? The redox reaction or the redox word has come from two words, reduction and oxidation. What is reduction basically? Reduction is basically addition of electrons. Oxidation is basically removal of electrons. It is basically addition of hydrogen. Addition of hydrogen. It is removal of hydrogen. It is removal of oxygen. Removal of oxygen. It is addition of oxygen. Or if I say it in terms of oxidation number, it is the decrease of oxidation number. Oxidation number decreases. Here the oxidation number increases. Okay, ma'am.
Sir, what is the meaning of oxidation number?
Yes, ma'am. I'm coming to that point only. Actually, let us consider a reaction. Copper plus oxygen will be giving me CuO. CuO. In elemental state, there are number of electrons and protons equal. So the oxidation number is basically the loss of electron or the gain of electron, because we cannot remove proton from any atom. So in elemental state, everything is neutral. So the oxidation number of copper will be 0, and oxygen in oxygen the oxidation number will also be 0. But for oxygen in compound state or in combined state with anything, any metal, it is showing -2 oxidation state, and copper will be showing +2 oxidation state with respect to this, because we have to make the neutral compound. So if I see the increase in oxidation number of copper, so it is basically oxidation. And when I look at this thing, when I look at the oxygen, when I look at the oxygen, its oxidation number is decreased. Oxidation number is decreased, so it is the reduction reaction. Basically, oxygen is electronegative element. Oxygen is having electronic configuration 2,6, and according to octet rule, every element should have 8 electrons in its outermost shell. So it will be gaining 2 electrons, it will be gaining 2 electrons, and it has gained 2 electrons from the copper. Okay, ma'am.